Hi, my name is Jakob, and I'm presenting my senior thesis on the sediment budget and Gully comparison of Martin and Little Indian Creek watersheds. This project has two main objectives: to establish a sediment budget and compare gully and landslide erosion in the Martin Creek and Little Indian Creek watershed. The secondary objective is to potentially determine the cause of these features using a national land cover database. The Martin Creek and Little Indian Creek watersheds were picked due to their shared boundary, and the watershed boundary was created using the watershed tool. The hillshades tool was used to create the hillshades for each watershed using the LiDAR elevation. These hillshades acted as the base layer for creating the feature classes for landslides, floodplains, and gullies. A sediment budget was then created using the landslides and gullies for sediment production and floodplains for sediment storage. This map shows the overall view of the two watersheds, with Martin Creek being in blue and Little Indian Creek being in purple. It also shows all floodplains, landslides, and gullies marked in each. The Martin Creek watershed, as seen in blue, has a total of 783 total gullies with an average slope of 34%. They had an average length of 273 feet, while the Little Indian Creek watershed, as seen in purple, has a total of 576 total gullies with an average slope of 30% and an average length of 288 feet. The Martin Creek watershed has a total of 11 landslides with a total area of 260,000 feet squared and an average slope of 15.5%. The Little Indian Creek watershed has 10 landslides with 370,000 feet squared in area and a 15.4% average slope. The top image on the right is located in the Martin Creek watershed, while the bottom image is located in the Little Indian Creek watershed. The floodplains in the Martin Creek watershed have a total area of 25 million feet squared, while the Little Indian Creek watershed has a total area of 18 million feet squared. On the bottom left, you can see the drawn feature class opposed to the base hillshade layer on the right. The sediment budget was created using four main parts: sediment production, sediment storage, sediment yield, and sediment loss from storage. The sediment production portion was evaluated over a 100-year span and used an assumed depth of 3 feet and a width of 10 feet based on field-confirmed landslides and gullies. Sediment storage also used an assumed depth of 3 feet based on field-confirmed floodplains. Sediment yield was found using USGS data from a similar river, and sediment loss from storage was determined by finding the difference between sediment production and sediment yield. One of the main results of the sediment budget is that the sediment storage primarily acts as a source rather than a sink, based on the diagrams to the right. On the NCLD layer on the right, you can see the primary two land uses being forests and pastures, with forests being the more prevalent. The primary of the gullies being located in forests suggests that they may have been formed by improper farming techniques in the past, as these forested areas would be less likely to have such heavy erosion. Based on this, I believe that a majority of this land was originally cleared and used for farming. This would mean the forest grew later, after the gullies formed and the land was no longer fit for farming. On the image to the left, you can see an example of contour farming within Tennessee, suggesting that if these hills in this area are being farmed with proper techniques, they were more than likely being farmed before these techniques were discovered. In the image to the right, you can see a gully found in the Little Indian Creek watershed that was helped to use in the sediment budget to determine depth and width. In the image to the right is a landslide located in the Little Indian Creek watershed. This landslide was one of the ones considered when determining the average depth used in the sediment budget.